Video number 125, writing the equation of hyperbola. Write the equation of hyperbola with eccentricity 1.5 and vertices 210 and 22. Well, if you put a graph up if you put just a piece of the graph anyway, we can definitely get moving in the right direction because we'll know what the picture looks like. We know this is a vertical hyperbola because it says the vertices are here. If 210 and 22 are the vertices, this is definitely a vertical hyperbola. We know the b value is 4. It's actually a b value because these are the vertices. If they told us the foci, if it said foci, then we would then say the c value was 4. Okay, so this is a little bit different than the ones perhaps you've seen in your notes, but this is definitely the same strategy. You've got to be careful. This is definitely the b value because those are vertices rather than foci. Maybe the next one we'll do foci instead. All right. So what we have here is we have a b value of 4, therefore b squared 16. Then we're going to solve an equation. We know that the eccentricity is 1.5, so we can do 1.5 equals c over 4. Multiply both sides by 4, c is 6. Whew. Therefore c squared is 36, which we're going to need in a second here. Alright, this would be the equation if the center was at the origin. We would use this, but it was obviously translated away at 2 comma 6. X minus 2, y minus 6, there you go. We know that b squared is 16. We don't know what a squared is. We're going to find out what that is. We know c squared is 36, so therefore a squared is 20. Therefore, we then solve for a squared, and we get a squared is 20. So now this is the equation right here. In fact, we don't even need to know what a is. Pretty interesting. We don't even need to know what it is. So this would be the equation that has this particular eccentricity and of course those vertices. Alright? Let's take a look at another one. We got write the equation of a hyperbola with eccentricity 2.5 and vertices at 5, 5 and negative 1, 5. Let's burn through this here. Eccentricity c over the first number. So the first number would be 3 because if you did a quick graph, 5, 5 puts us here, negative 1, 5 puts us there. Okay, I'll put the 5 on the other side. Then our center would then be 2, 5. You agree with that? Okay. Now these are the vertices, so therefore we're going to go this way. Okay. Now that sets us up for an x squared over a squared shape hyperbola. Then we're going to go ahead and put a 9 here because we know that a is 3, therefore a squared is 9. How do we know a is 3? Because this has got to be 2. How do you know that's 2? Well, this is a 5, 5, and this point is a negative 1, 5. Well, how far is it from negative 1 up to 5? That's a total of 6. Half of 6 is 3. So you go 3 this way and 3 that way takes you to a 2. So that center there is 2, 5. Okay? That's going to help us here. X minus 2, y minus 5. Then we just need to find out what b squared is. Well, we know that a squared is definitely 9. Okay, because a is 3. So therefore we use the Pythagorean Theorem. And we have c squared equals a squared plus b squared. How did we get 225 over 4? Well, when we did the eccentricity, we got c equals 2.5 times 3, which is 7.5, and which is 15 over 2. So c is 15 over 2. Therefore, c squared is 225 over 4. That's right here. Okay, subtract. Then what we did here is you multiply everything by 4. That cancels this 4, 36, 4b squared. Subtract 36, divide by 4. And you've got a squared is 9 and b squared is 189 over 4. Then you invert this fraction, dividing by a fraction, multiply by the reciprocal, and then this is then our final answer. Okay? Let's do one real quick. Let's just make one up. Let's do one where they tell us the foci. Let's just make one up. Let's say the eccentricity is 2. And the foci are at 6, negative 1, and 6, negative 5. Okay? Well, let's put a graph here. So 6, -1 is right here. 6, -5 would then be, that's a 5 here, right here. So where's the center? Whew, right there. Definitely the center of this hyperbola is here, which would be at 6, -3. Now, these are the foci, which is different. Foci number 1, foci number 2. That's definitely different from vertices. The vertices would then be somewhere over here. We don't know where they are, but they're between the center and the foci. This makes things a little bit different, because what are they telling us? They're telling us now not the b value, but the c value. They're telling us that c is 2. Therefore, c squared is 4. So then when you do eccentricity, okay, eccentricity is definitely c over, in this case, b, because this is a vertical hyperbola. You would then have 2 equals, well, eccentricity is 2, right? So 2 equals 2 over b, which would then make b equal to 1. Okay? So then we would go from here. Let's continue on the notepad here. So we would have all this information. So then we would then say, all right, this is definitely a y squared over b squared hyperbola. X squared minus x squared over a squared equals 1. This would be at the center. Our center is 6, 3. So we're going to have y plus 3 quantity squared minus x minus 6 quantity squared. Now you're going to have your b squared here, your a squared there. That's a 1. Your b squared is going to be 1 squared, which is 1. And then your a squared, we need to go back into the Pythagorean Theorem. So we're going to do c squared equals a squared plus b squared. C squared is definitely 4. A squared we don't know. B squared is definitely a 1. So does everybody agree a squared is 3? There you go. Put a 3 here, you're a happy camper. So if you really wanted to clean it up, you could put y plus 3 quantity squared minus x minus 6 quantity squared over 3 equals 1. You don't have to put the 1, but this doesn't really come up that often. But yes, this would be the equation for if they gave us the eccentricity to foci, the foci instead of vertices. So we definitely wanted to show you the 2 different cases. And good luck, good times. Talk to you later.